Привет всем. Hello everyone. This talk is going to be in English. It's about using JMH in a real-world project. Real-world means enterprise, something for which somebody pays money. Has nothing to do with benchmark in the real world. About me, I'm software engineer at Sowatec AG in Switzerland. Basically write soft for Swiss banks. I'm also one of these organizers for Java-conference, the literally hottest Java conference in the world, and also some my blog on Twitter. Okay, so what I'm going to talk about? I'm going to talk about benchmarking, just a definition what I mean by that. Quick intro into JMH and how we use JMH in our project, and share some optimizations war stories that we had fun with. So what's benchmarking? Benchmark essentially it's measurement and comparison. It comes originally from financial sector when you compare your performance of your processes and departments against the standards defined in the enterprise. What I mean by benchmarking is that when we benchmark, we want to assess performance of our system or component, or we want to compare performance of different algorithms and implementations, or we want to investigate an impact of configuration change, or let's say change from Java 7 to Java 6, or sorry, Java 7 to Java 8, of course, you're not going to go to 6. So we want to do good things. There are other aspects of benchmarking when you want to troll people and when you want to go into flame wars. I'm not going to touch on that. Alexei covers that nicely in his performance talks. So benchmarking seems to be a cool thing, but here is the slide of caution. I'm going to quote Cliff Click here, which said that without every exception, that every micro benchmark that he ever seen had a serious flaws. And the thing is, that's very true for Java when you run on the dynamic platform, like let's say CLR or Java, when you run VM. There are lots of things that happen underneath which will screw your performance analysis and measurements. So let's ignore Cliff for a second, and let's say I want to analyze how cool and how much costs the list get in Java. So I write some code, I put in billion iterations here, and I say here in the loop, I say list gets 3, gets first element, and then I time it. Who thinks this is a great thing to measure? Who thinks this is a valid benchmark? Raise your hands. Alexis thinks it's great, okay, awesome. Who thinks this is not a good thing? And who knows why? Does it measure anything?
No.
Okay, yeah.
It provides you with the time, so it does matter.
Yeah, exactly. Let's have a look. That's my time. I run it, I see, wow, it's executed in 2 milliseconds, and the cost per operation is 0, 0, 0, I don't know how many zeros, 2 point something nanoseconds. And like, okay, this is funny. It's run on this laptop. It has like 2.7 gigahertz. Let's just downsize it to 2 gigahertz, which means per cycle on this machine I can per nanosecond I can execute basically up to 2 cycles. And here it says I can execute like 300 or 400 cycles. It cannot be. It just busted. So, okay, lesson learned. You cannot write benchmarks, especially in Java. Let's go home. Well, you cannot write them, or you shouldn't write them bare hands. You shouldn't try to do that. Luckily, good guys at Oracle, in particular the performance team, they're pointing each other's fingers at each other, Sergey and Alexei, have invented JMH. If I'm not mistaken, this is the third or fourth rewrite of the benchmarking harness inside Oracle.
Yeah, fourth.
So it's a fourth rewrite thing. So JMH stands for Java Microbenchmark Harness, but actually it supports multiple languages. You have Scala, Kotlin, Groovy, and Java. And essentially you can measure anything that runs on JVM these days. You use it to write all sorts of benchmarks, from nano to macro benchmarks. These are related to how long or how big is the operation you want to measure. So nano benchmark relate to nano effects like a single method call or even below that. And like macro benchmarks, you run something that runs for hours or days. And this is de facto standard for writing benchmarks on JVM. Also, it's a tool that now used by a lot of people to blog and say, I wrote it in JMH, therefore it's correct. So remember, a fool with a tool is still a fool, so don't think that the benchmark written in JMH is any better than the other one, but it gives you ability to write correct stuff. So JMH has lots of features. We have, in essence, it's annotation-based framework or library. You use annotations to write your code, and then during the build time, annotation processor will generate a lot of code to do actual measurement. So you write what you want to measure, the tool does the rest. You have super cool support for parameters and internal state. You can write very interesting, sophisticated multi-threading benchmark. You have access to low-level things like compiler control, black hole for results consumed, etc. This is all awesome. What I also like is that you can use command line and the API to run in benchmarks. This comes in handy when you start building a harness of your own benchmarks and you have a different execution modes or different parameters that you can only set by command line, so you can use the API to do the job. And the most awesome thing is the built-in profilers. This is just absolutely jam with the thing. So how would we write the same list get thing in JMH? Well, we'll do something like this. We create a class, we have an add benchmark annotation, and we have a list access. Notice here that the thing in the benchmark is the thing I want to measure, just the list get. The rest is somewhere else. So I have a setup part where I create my list, I initialize my index, I have some other supporting annotations like that I want to have a state, therefore I can have fields, etc. But the most important thing here. So now if you run this, we get the following results. So now all of a sudden list get costs 4.2 nanoseconds, or 1.5 times different from hand-rolled. So I would rather believe this number than another one. This was also can be verified if we create, for instance, here an empty benchmark method and see that it also costs something. So the harness makes sure that even if you have an empty method, it's going to call it and measure the cost of the call. Unlike your own implementation, which will be just that code eliminated. Yeah, the harness has several modes. This is just for your reference, not going to touch on them a lot. Profilers, I will just quickly mention that these things here, based on perf, an absolutely amazing thing. When you do anything serious with micro and nanosecond benchmarks, you usually need to look at assembly generated by JIT. And basically with these tools, you can get it. Again, this is just for reference. Regulo. I'm working at an organization which does lots of financial software, and of course, as any enterprise organization, we must have internal framework, right? Otherwise, we're not going to be enterprise. So I work on this thing called Regulo. This is our internal framework to do projects. It has lots of interesting features, workflows, reporting, you name it, dynamic data modeling. So the story of us using JMH in our project was that at a certain point, people start complaining about performance. They say, what was working 5 years ago is not cutting in new projects, you have to do something about it. So we came up with something like this. We said, okay, let's do it correctly. Instead of just jumping and profiling and fixing and shipping the version and then going to the next one, let's create certain kind of approach, how we can do it. So we looked at unit testing, for instance, and we said, well, if we implement a feature or fix a bug, first thing we do, we write a test, failing test, and then we fix it. Then we know that we achieved something. So we can do the same with our performance optimization. So it starts with we identify a use case, or somebody complains about a use case which is slow. We try to do this, set a performance goal. This is very hard if you do a framework kind of thing, because the expectation is it must be faster and faster. You cannot just say, if I make it 2 times faster, is that enough? It might be enough for today, but might not be enough for tomorrow. But we try to kind of negotiate at least. What is the performance improvement you want to achieve? Then you write 1 or more benchmarks to cover a use case. This is very important, especially word more, because usually people report only one aspect. Let's say they tried it with one kind of product or was, I don't know, Monday mornings and never tested on Friday dates, etc. And if you just optimize for Monday mornings, then you will make sure that Fridays will be slow. So you have to strike a balance. Therefore, you write more than one benchmark and see how how the things behave. Of course, then you figure out what to fix using your normal profiling tools, or starting with the help of built-in JMH profilers to start digging into the problem. Then you apply the fix and see if it was correct or not. If it does improve positively, thing you're measuring, you accept it. And in the end, you go on like this until you say, okay, did we reach a goal? If yes, we stop. Or otherwise, we check what is the cost of fixing it. Let's say somebody says that certain thing must be 10 times faster, and we made it 5 times faster. And we see that going from 5 to 10 times is going to cost us 3 months of engineering. At this point, we just say, well, we're not going to do it. Sorry, guys, it's going to be 5 times faster, and that's it. You have to live with it, and we have to find other ways to do the same thing that they're trying to do. So our setup, we use Gradle as a build tool, unlike JMH that by default comes with Maven build. The only thing that you really need from the build tool is that during the build phase, you need to run annotation processor, you want to capture the generated benches, and what you want to do, you want to generate a fat jar. A jar which has your benchmarks and your dependencies in one big pile. And the reason you want to do it is that then you can take this jar and put on any environment you want to run. You can share it with someone. You can say, can you confirm results, etc. So the same as in Maven, we use Gradle. We have a Gradle plugin. I'll show you in a second about that. We also use some custom runner. I will show also the code and explain why we do it. And the most important thing, we have a performance environment. In our case, it's a single machine, but nevertheless, we are isolated from all the effects, from the network effects, from the database effects, etc. We have all in one box, and that's not the most realistic thing. For instance, when you have database and the server on the same machine, but at the very least, it gives you isolation, so you can compare previous run with the new run. So Gradle plugin. The most important one is here. Use a plugin. Here's the section where you can set parameters. We use latest JMH stuff. Another thing to mention was here that we use another plugin called Shadow, which allows us to do this. If you are familiar with Maven Shade, you have transformers which allow you to control the process of building the jar. This is important because if you have dependencies that have, let's say, services in meta-inf declared, if you merge them together, then you're going to destroy the services and this thing not going to run. The same going to happen with JMH plugin by default. It will just try to put stuff together and override the files and will screw you up. But if you also put a shadow plugin and apply it before it, you have access to the shadow plugin, which is essentially rewrite of the shade for Gradle. So then you can say, okay, you know what, we have Spring. Let's merge this stuff together so the Spring will actually run when you have a fat jar. Yeah, custom runner. For better or for worse, we need to do certain configuration that doesn't allow us to start our application directly from command line when we have fat jar. So we use full power of JMH API, and this is awesome. So here I'm starting with options builder to build my options, but important line is this, where I say new command line options. What it allows me to do, it allows me still to pass some arguments to override behavior of my benchmarks. For instance, how many threads I'm going to use for benchmarks, number of wait iterations, warm-up iterations, etc., all sorts of stuff. But also afterwards, I'm setting some parameters hard-coded for reasons I will explain later. Cool stuff, you can do all different things, very useful when you want to rerun your benchmarks with different parameters, but you cannot change them through annotations, for instance, stuff. Results processing. This is a bit of a facepalm slide. Exactly. What you do with the results? Well, you measure, you get the output of JMH, which you can get in CSV, SCSV, TXT, JSON, and what, God forbid, whatever formats. There's all sorts of stuff. We kind of fail in this respect right now. We stick them in Confluence. So here's just a screenshot. We have one run, another run. Somewhere there it explains what the numbers means, like is it seconds, is it nanoseconds, is it days, or what the hell it is. And then you have to read across the line and see, do I have regression, or does it actually improve and stuff. It doesn't scale. So if you have lots of benchmarks or hundreds of benchmarks, you have several screen folds, and if you have lots of runs, it's painful. We have to improve on that. That's next on my list. But as always, in enterprise, somebody pays you to do actual work and not improve your own stuff. There is a Jenkins JMH plugin I have to mention. This is very bare bones. You have to build it yourself, first of all. And the only thing it allows you to do, it allows you to capture the files and attach them to a build. So if you're familiar with Jenkins builds, every build you're going to get files saved. And the plugin just builds you the index of the files. So you can say, okay, I have 50 builds. Here's my 50 files. And then whatever you do with these files is your own problem. You can plot them, you can analyze them, whatever. Unfortunately, there is no built-in plugin like for JUnit, which will say, you know what, you have failed certain benchmarks, or you have performance regressions. It would be cool if somebody steps up, or yeah, it has to be done. Now, when you start using JMH in the project, you discover certain issues. That was at least my experience. First thing worth to mention is default timeout. Default timeout is a means of JMH of protecting itself from infinite benchmarks. So if you run a benchmark and it doesn't respond in 10 minutes by default, it's going to kill it. What it counts as this time as time for setup and teardown as well. So not just your run of your benchmark. However, if you have a big benchmark, what you usually have to do, you have to prepare some data in the setup. And in some of our cases, the setup was taking 45 minutes to run. So what would happen, you would sit there in 45 minutes in the setup, you would prepare data, and the very moment you get out of the setup, JMH would kill your run and say, you know what, you failed the timeout. So that's why in the runner, we set timeout to 1 day. We say, okay, if within 1 day our benchmarks don't respond, let's kill us, but otherwise allow us to do crazy things. Because usually we run the benchmarks on the empty database, and we have to generate a lot of data model, insert lots of objects, and do lots of crazy stuff, and that takes a lot of time. Another issue, especially if you're into some internal state, is that when you use setup and teardown and multiple threads, there is no guarantee of which thread gonna do what. So if you're on single-threaded benchmark, it's easy. You have a worker thread, it does your setup call, it does your benchmark call, it does your teardown call. But if you have more than one thread, you can have thread 1 doing setup and thread 4 come and do teardown. The result is, if you in setup created some kind of running server and hook it into the thread local, in the teardown you cannot shut down because there is no thread local in the thread you want to do. So we had to do some massaging on our side to make sure that the stuff that we run, we can shut down from any thread. Last one, really small one, but still interesting one. Because JMH can measure everything, including what is the performance of throwing exceptions, it doesn't stop on exceptions. Exception is okay. So you have this fail on error flag, which is set by default to false. And if your benchmark basically encounters exception, the run will continue. For us, it was bad, especially when you start writing your benchmarks, because you may have errors, or let's say you making a new major release of your product and you change something in the core data model, but you didn't update your benchmark code. So what would happen is that 10 hours in the run, the benchmark will encounter the exception but will not stop. So at the end you have your results, but some results for some benchmarks will not be published. So they will simply disappear. So kind of you get the run but with incomplete results. So we just set it to true. Unfortunately, there is no annotation to do that, so you have to do it like this. So here comes my wish list for JMH, and I can show it to Alexei. What I would love to have unified annotation and command line option. For instance, if I can do GC from command line, I should be able to do it with the annotation. Because in my benchmark suite, I have maybe 5 benchmarks that needs the garbage collection control around invoking iterations. But for the rest, I don't want the overhead of calling GC and waiting on that. The same comes for fail on error. I might just say, by default, have an annotation fail on error too. Threads and params, my favorite one. In params, if you use params, you can specify multiple values. So you can say 1, 10, 10,000, 1 million. If you use threads, you can only put one value. So you cannot say, I want to run my benchmark with single thread and then with 4 threads. You have to run it 2 times. You have to say -T1, -T4, command line, or API. So it just tiny little things, but which make you think. Yeah, setup, tear down. I don't know how important it is. It was a bit confusing coming from tools like JUnit, where you know that the main thread does before class and after class, and no other thread. So you kind of have these guarantees. And the last one will be nice to have a JFR profiler integrator by default. Comes the fun part. Optimization war stories. So benchmarking and measuring, it's not the means to an end. You want to do something with your product, as I said. So let's have a look at something. This is called small things matter. You have some kind of pseudo code, more or less. What would happen to your domain object when you want to extract the values? Let's say you put them into the database. So you interrogate your object and you say, give me an array of values. So you allocate array and then you set value in the array. If you look closer here, this line, the first thing that happens, we get a type descriptor. What this domain object is all about. Then we get a property and then we put a thing in. So our profiling showed that this was very, very expensive. The problem is at that time we didn't have an easy way to fix it. So it's like, okay, this is expensive, this hurts a lot, how do we fix it? Well, how about we do this? This. We took this line from here and we moved it up. So what we did, we just say, hold on, you're calling the method setValue, and every time it does getType. Why cannot we call getType and pass it on? So let's say if I have 50 properties, I just reduce the call to getType factor of 50. The surprising thing was this. Just by moving this one line and 1 hour of refactoring, our build time was down by 40 minutes, or 25% of total time. So at that point, we were 3 hours building our CI, and all of a sudden, we're like 2 hours 20. Like, what just happened? We moved one line. All right. Now, this getType thing is expensive. We found out, OK, we need to fix it. In essence, what this type is, and every domain object has like a type descriptor ID, which is long. So in a way, it's a sort of, by a long key, you need to get an object from a map. So here is a JMH bench with omitted parts. By the way, the benchmarks, all the benchmarks and numbers I show here, they are published on the GitHub, so you can have a look at the benchmarks, verify for yourself, run for yourself. So what we do here, I compare the speed of concurrent hash map from JDK with non-blocking hash map. If you're familiar with the name non-blocking hash map, you would realize this is CliffClick's high-scale lib library. That's what we started with. I will say in a second that that's not what we use now, but we still use CliffClick's work. So just gets, let's have a look. Was it worth it? So if we look in Java 7, we have concurrent hash map and non-blocking hash map. We have more than factor of 2 difference. And the thing is here, whenever I call concurrent hash map, I have to allocate an object. Because I have a long primitive, it must be turned into, boxed into a long object. And just while running this benchmark, it generates 1.3 gigabytes a second of garbage. And this is bad. So, all right, what if we go next generation of JDK? Is it better? Wow, this is much better. Look at the concurrent hash map times. They went down a lot. We still generate garbage, but nevertheless, we are almost closing the gap. This one is still better because we don't generate the garbage. So we don't put pressure on memory allocator. We don't put pressure on garbage collector. Now, here's the warning. If you are using the namespace CliffClick high-scale lib from the SourceForge, stop it. This project is abandoned. Last commit was in 2011 or 2012. And most recent version of his high-scale lib available actually in his water project, an H2O organization in which he works now. So there, it's embedded inside the bigger product. There is a package water NBHM, and all the classes, non-blocking hash map, uncontended counter, non-blocking hash map long, all there. So use it from there. And the reason is I'm saying there are bugs. We started with high-scale lib version. And the problem is, if you use a 0 as a key to the map, it doesn't deliver on promises. It fails to put proper barriers. It fails to do a volatile read, and essentially we have a concurrency bugs. I reported it. There is a test case, and Cliff then replied to me, "Don't use that project. Use something else." So, good. You've also probably noticed on another slide I'm talking about little things, but these little things had a huge impact overall once they were solved. So one of the things we have to do, we have this property, so each domain object has a type descriptor, has a list of properties, and you have to do property lookups by key. But the contract is that it's case insensitive. So anybody can call get property with any case. So if you're on JDK, you normally do this, tree map with case insensitive order, or you do hash map and lowercase on key. Or you do something clever. So let's have a look. I have a bench here. So hash map, key to lower, tree map, and the clever bit. So what we try to do here, the ignore case map is actually just a hash map. First you try to look up by key. If you don't find it, you look up by lowercase of key, and if you find it, you put it back into the map. So it doesn't work in general case where you want to make sure that you have only one mapping from key to the value, but it works as sort of caches or internal dictionaries where you have a control. In order for this to work, you have to make sure that when you put, you also put a key and a lowercase. So you put two mappings simultaneously into the map. Okay, that's all interesting, but does it really make sense? So let's have a look. We started with a tree map. Good key is the case when key exactly matches the case what is stored in the map. Bad key doesn't match the case what is stored in the map. So we see we have certain 100 nanosecond time. Hash map to lowercase is better, but we generate garbage. We generate a new string object every time. If you look on our ignore case map, we're somewhere from 7 to 15 times faster than our tree map case. And this goes across JDK, doesn't change. So that makes sense. If you have this requirement, what I would say, if you don't have requirement to have ignore case, just use a hash map. Don't invent stuff. But if you have to, you probably have to pay attention to that stuff. Well, if you're an enterprise framework, sorry, I'm going to check on time. If you have an enterprise framework you're working on, you tend to reflect a lot. First of all, on your life, what I'm doing here in this organization so much and doing this stuff, but also in the code, you use a lot of reflection. Probably everybody knows that reflection is slower generally than calling methods normally, but what is the cost of acquiring reflective information itself? So what is the cost of calling get fields, get methods, etc.? You know, Java caches this information and using soft references, I guess. So if you have no pressure on a heap, you are good. The only problem, everything you get out of get fields, get methods, get constructor is a mutable object, because you can do things like set accessible true, because you want to set a final field or you want to set a private field. Because of this, you get a copy, and this copy has a huge cost. So here is the benchmark that measures plain class get declared fields access. The class is in a hierarchy of 3 classes and has only 15 fields. That doesn't matter. And another one, just to put a concurrent hash map in front of it, just to cache that access. Let's measure. On Java 7, we have 280 nanoseconds to make all this copy business, and only 11 nanoseconds. So it's like a factor of 26 difference. You have to pay the cost. If you go JDK 8, it gets better. Declared fields is 4 times faster, but still, this implementation beats it almost by a factor of 10. So if you're into reflection business, make sure you get it once. You don't want to pay these costs all over again. Plus, because it's a copy, you generate memory traffic, you put pressure on garbage collector, etc. Now, related to the reflection, one of the things we had to do is essentially create objects. So, well, create object called constructor. Well, we did this. As painful as it is, we just, every time somebody wanted to create a domain object, we say, oh, we know the class name, let's load the class, call constructor, call the instance, lots of stuff. Okay, you can do better, and here's all the different things. You can call new, right? If you have an object and you don't have to go through reflection, you can do this. Or at least you can make this dance once, have your constructor, and say constructor new instance. So let's see what is the difference of calling that on JDK 7. So first of all, you noticed that calling constructor directly and calling it through reflection costs you a lot. It's a ginormous difference. But also, calling constructor versus doing all the dance that we were doing stupidly, it's about factor of 6. Okay, so we can improve by factor of 6, but still there is a huge gap. But look what happens when you go JDK 8. Notice this. It's only 40%. It was like, I don't know, 17, 16 times. So the team at Oracle did an amazing thing here. And now, see, if the optimization that we did actually was to cache constructor, right? So if before it only gives me a factor of 6 difference between these two numbers, now it gives me more than a factor of 40. So on JDK 8, it even makes more sense to cache that reflective information, even get more benefit of doing that. And we almost closed the gap with reflective versus not reflective call. Yeah, this is actually not an optimization war story. It just came out recently during the debug session. While stepping through the thing on array list add all. So on this call, I've noticed there is a line which says underline collection dot to array. So if you want to copy data into the array list, first it creates an array from the collection and then does an array copy. And like I said, well, hold on, it doesn't make sense because you already iterate over all the elements and you just want to put them in the array. So I said, I'm clever, I can do better. I can do this. And of course, just for measurement comparisons, what is the difference between call and array list? Well, it depends. It depends highly on your underlying source collection. So if my source collection is array list, calling to array on it is essentially a single system array copy operation. So if I create array list in the constructor, it just does a single array copy. If I do add all, there are two array copies. First, it does array copy to get from array from the source array list, and second one to copy inside the destination array list. So we have factor of 2 here. And my naive attempt to say I'm going to iterate and going to do stuff fails miserably. So you see it's factor 15 between the stuff. Because the system array copy is highly optimized, can use tricks like vectorized instructions and stuff, copying chunks of memory instead of you doing pointer chasing, that what Martin was saying, and trying to find your data. However, if your underlying collection is only hash set, then you dominated by cost to call into array on this hash set. And this is just basically going through iterator. But nevertheless, if you see here, doing manual add is still the slowest part. So don't think you're clever. Don't try to find better ways to do stuff. Yeah? This is run-to-run variance. There was only single 1 or 2 forks, or 3 forks, I don't remember. I didn't run enough iterations and didn't run enough forks. Good point. I can't. I'll run more experiments later. That's a good job. Coming back to what we heard during the keynote today. You want to design your API for performance. Our story was something like this. We have a manager of managers. As you know, in all enterprise code, you have managers for something. We have a thing called object manager. And through that, you can do lots of things. And one of them, you can write your objects into the data storage. So originally, we exposed a method to write an object at a time. What it means is that developers who use the framework write the loops around, write, if they have, let's say, 1 million entries to write, they have to think about transaction boundaries and stuff like that. And they are limited in what they can do. They have only this API. They don't have access to the underlying low-level stuff. What we did to fix the stuff, we just gave them a method. And originally, in the release we introduced that, we just did the same. We introduced a loop, we write objects one by one. However, because we own the framework, we know that we are doing JDBC underneath. And we use JDBC batching, and we cut performance by a factor of 5 by just batching and writing in tens of thousands of objects into the database. Now, know your use case. That's a funny one. We have, as I said, the framework provides tons of different features. One of them is a thing like a pivot grid. If you know the Excel, what the pivot is, the smart pivot table. So somebody reported a use case which says we have a pivot with 2 different configurations. Group it like this. You have 25 seconds, and you have 31 seconds, or 1.5 seconds. They even reported half a second if it was any significant. So we went in and said, okay, actually, looking at the configuration, what you actually do there, we can write a single SQL query to do the same. So we can compute all the sums and averages right in SQL. And we got from 24.5 to half a second, so it's 49 times faster. And here we got another 8 times. Right, you go to a boss, you say, let's go drink beer. You build a new build, you give it to the product team, and they say, it doesn't help. Nothing works, it's the same. You start digging and you find out, well, the difference between this and this, it's all the same. We have to repeat, we have the same amounts of data, but one Boolean flag on the data. You have certain data that you can persist or not persist. So they used a non-persistent attributes while computing this. Non-persistent attributes means they are not in the database. They have to be computed on the fly, and therefore, all this optimization that goes directly to the database to do business doesn't work. So you really have to know exact use case when somebody reports to know, are we measuring what people are reporting? But now we have 2 cool implementations. One is really fast, another one got faster over time, and at least you can you have a chance to say them, well, persist your data, and then it will be faster. Well, as in any enterprise application, you have to have your n+1 SQL problem. Luckily, we are not using Hibernate. Unluckily, we had n+1 SQL problem. So if you're familiar with structured data master details, for instance, you have orders and order lines. So order has a collection of order lines. What Hibernate will do by default, you read, let's say, 1,000 orders, and if you don't access in order lines, you are fine. But the very moment you start saying order, get order lines, you get a SQL to load order lines for this order. So if you have 1,000 orders, you have 1 SQL to load orders, plus 1,000 SQLs to load all the items. We had something like this. It was even worse because our master detail loading is not lazy, but eager. So every time you get orders, we're gonna stuff in your order lines there. And the problem was we were doing this n+1 SQL thing. Of course, this was stupid. You can do it in 2 SQLs. You can have 1 SQL to load all the orders, plus another SQL to load all the details based on the filters for the master. Huge wins on like factors of 15 or even more on certain benchmarks. So in closing, where we stand. So it was fun to use JMH in the product. We have now a baseline from which we can continue our work. Just the build time on the CI, which is not related to performance at all. This is just our standard unit test-based build went down from 3 hours to 45 minutes based on all the performance work we did in the project. I was also surprised that we wanted to cut down these times, but not through optimizing product for real things. We caught one big performance regression, and on average, when people update the product, it feels faster, and in certain cases like the pivot grids and other stuff, they get some X performance better. And if people start using the new APIs, like writing to the database in bulks and other stuff, they have really massive improvements. So with all that, I have references. This is the slides, this slide deck. The benchmarks in the GitHub, which are questionable in some numbers, that needs to be running are here. So anybody who wants to go, you'll find them there. And with that, do you have any questions? Yes, please. I will try to go there. You mean this one or the one with Java code?
My question is about the very first test you made, and I'm just wonder. I'm curious, what was the reason of extracting the index variable into a separate field?
Yes.
And would it make any difference just to inline?
Well,
I'm pretty sure it will be.
This stuff here, the index is not 3. There it was hard-coded, here it's not. Well, here I'm following a lead of JMH samples, which says you shouldn't use constants. In this particular case, I was running it without constant, it was more or less the same time. But in general, for instance, if you have a mass.square root or something like that, if you would put a 3 there, then compiler will be happily, essentially JIT compiler will run for a couple of iterations, will figure out that the value doesn't change, will hard code the value, and the method will just return. It will not cause square root anymore. In this particular case, when you have a field to read, you just forcing the compiler to say, well, I don't know what this thing is, so I have to load it and then call your load. That stuff, it has something to do with constant propagation, constant folding and stuff. Alexei can maybe comment on that.
It works only specifically in JMH. If you do the regular Java method, that chances are it will get in line and the constant will be provided from somewhere. Just
Okay, so JMH has something to fight that. So that in the normal code, if I would go back and put here an int index 3, is still going to be the same, basically. It's going to be in light, and the effect will be the same. So essentially, it comes from samples. If you read samples and learn about JMH, you quickly figure out what are the fallbacks, or what are the drawbacks, what are the blind spots you have to watch out for. And it also helps if somebody reviews your benchmarks, of course. Somebody can say, well, this is bullshit, you know, this is going to be optimized the way and stuff. Anybody else?
One question about your timeouts per test. In JMH, timeout is set per benchmark or for all run?
No, per benchmark. Timeout is per benchmark.
You have timeout for a single benchmark 1 day. And if you by mistake add a forever loop in some way in your core, you will have your all benchmarks run for months. Am I right?
Yes. If every of my benchmark steps on that infinite loop, it will not finish within 1 month. Well, I now know more or less what is the running time for a bench suite. It's around 38 hours, all in all. And the problem is not even running. The problem is preparing the data, because we're starting from scratch and all the data thing. So if it's not going to run within the 2 days, I know something went wrong, so I'm going to go and kill it and go start hunting for that. Yeah.
So I want to ask, timeout, maybe you should switch timeout off. I think in your case, timeout is not used at all.
Well,
1 day, I think it's not a
I will tell you about this thing. Timeout counts this time as well. Time around spent in setup and tear down. So if my setup takes 40 minutes and my benchmark runs 1 second, doesn't matter, because benchmark will not be run. The very moment I get out of the setup, JMH will stop running.
So I suggest you to set timeout to infinity. I think, am I right that in your case it's equal to 1 day?
Yeah, it's sort of infinity. It's sort of a kind of like.
It's the practical value for infinity, 1 day.
Yes.
Oh.
It's a practical infinity within. It's 1 working day. You know, you're not in the office, then it's infinity.
Okay.
Yeah.
Thank you.
Next one.
Have you tried to use normal Java profilers, not microbenchmarking harness, to do the same thing? I guess it would be easier to do because you don't need to write any special code. And
Yeah, well, first of
I guess
all,
most of these problems would be code as well.
well, the thing is, yes and no. First of all profilers lie. There is not a single tool which will tell you all the truth. I mean, you have sampling profilers and you have instrumented profilers, and each one lies separately. Guys in the audience done talks on that. I think Sergey has some talks on profilers. And the problem is not to use a tool to find out. Actually, once we have a benchmarks, first of all, you have an isolated case. You're not running your whole application and saying, oh, user clicks through 10 different screens, and then it invoked that report, and then 2 hours later, you have that magical time when you can push the button. You have exactly that magical time to push the button underneath, so you extract it in the code. And then you use your normal profilers, whatever you like, a flight recorder or Visual VM, NetBeans profiler, whatever, you run it against that code instead of running against your whole application. The main advantage of having a suite of benchmarks is like a regression suite for your unit tests. Once you put them in, they tell you the health, how healthy your product is. That tomorrow somebody puts a new feature and all of a sudden the performance on 10 different use cases just drops down off the cliff. So if you just profile, you would not know that, because somebody will say eventually half a year later, something is wrong. Now you go start profiling again, hopefully you will find it, but there is a big difference and big window. Of course, storing result in Confluence doesn't help you to catch performance regressions. That's another story, but at least you have a chance. Let's put it this way. By the way, I would like to ask audience, who here uses JMH to do also any sort of serious work? Okay, see a couple of hands. What you do, guys, especially maybe Oracle guys, what do you do with the results? How do you process the results? Can you pass the mic there, maybe?
You look at them.
My English is not so good, so I just try. I mostly just review results because I have not so lot of time to do that regularly. So.
But basically, you look at the results you have a run, you look at the results of this particular run. Do you analyze benchmarks over time? What happens within the last 6 months or something?
In most time, I have to optimize product. It's not continuously, just 2 times per whole, per year.
Okay.
And,
so when you have performance problem, you look at the benchmarks. When you don't have performance problem, we don't look at the benchmarks. Okay. Nice way to put it. Maybe Martin, want to comment on that?
I find a useful thing is to capture them and put them in a database and then graph them and put them up on big screens. Just like you have your CI feel, screens go red, graph your performance, it changes people's behavior with how they interact to it. People don't like to see a graph going down, they like to see it going up, so it affects the behavior of the team, tends to work quite well. Also, your long runs, a kind of interesting comment on it. Have you tried doing things like git bisect whenever you get a performance problem? Because like, which commit caused the problem, especially when you take 30 plus hours to run tests?
Yeah, I mean, we use, I didn't try the Git feature to look into which commit caused it, because at the time when all this started, we did a transition from star team. So we had a horrible system. Eventually we got to Git, and at the same time we were also dealing with JMH and stuff, and that's why we had our performance regression. And actually, not even us spotted the performance regression. The product team, who has their own set of benchmarks, kind of been running our builds, and they just said, oh, that number went down twice. They were quiet for several weeks. We did several patch releases, and again went down several times. And then they come back like, guys, something is wrong. And like, why didn't you scream a month before that there is a performance problem? But well, yeah, it's a bit of, in any organization you have the silo kind of thing that everybody's responsible for his own stuff, and at the end you get to blame, because if you do something low level of framework-ish, whatever, you're gonna suck. It's the same for probably JDK guys, right? Whenever everything wrong, it's JVM problem, right? It cannot be in the code of someone else. Anybody else has any
So yes,
comments?
we do the same thing. We do benchmarks on a regular basis, and we save them in a database, and we do graphs. And especially if you do it on different platforms regularly, it's convenient to see if you have shared changes which cause a performance regression, or if you have platform-dependent changes which cause a regression. And you also can exclude machine problems, like different things like no memory on one machine, or network problem, or so, if you do it on many different platforms. So I think graph is really the best thing you can do.
Yeah, we are visual animals, right? So human perception is better for graphs than for numbers. Yeah, that's something we have to improve for sure. Some more comments?
Okay. One more. And is there any possibility to get kind of real-time profiling information for JMA test? Say, like I have a complex algorithm and I want to put some annotations, whatever, within code, and it'll say me this block took this time, and this block took this time. And again, one more question about garbage collection. Can we somehow connect JMA tests with profiling garbage collection?
Yes, that's gonna be this. First of all, I'm gonna start answering the second question first. If you want to know the GC effects of your benchmark, you can use -prov GC, and you see how much memory your benchmark allocates and how many GC cycles were executed and what the garbage collector was up to. It kind of gets you the basic numbers to start digging into. If you follow guy Kirk Pepperdine, if you know, he's the world famous GC expert, he has a rule saying that if your application allocates at the rate more than 500 megs a second, you have a problem. He usually wants to get it down under 500 megs. So if in my benchmark of this long key allocation, if I see 1.3 gigabytes a second, that would be a red flag for me to start digging into why do we allocate that much memory. Another thing regarding, can I put some annotation in my code and get performance information? Well, you're looking into some sort of measurement tool or stopwatch, or in the realm of HDR histogram, where you need a tool into which you can add these numbers and then process them later, but there is no magic in JMH that allows you to put some kind of annotation into your production code, and because the code that actually measures stuff, it will be generated. So that's not what you want to do with your production code. Anyway.
General question was about how to make fast drill down into problem. Say I'm benchmarking some long algorithm procedure, function, or whatever, and I want to do fast drill down without taking out blocks of code, because calls also cost something.
Well, you use profiling tools. Okay. You look into the thing. Depends on, I mean, you can start as simple as this. This is naive stack profiler, but it can potentially guide you somewhere. Might mislead you a lot, but you can just say, okay, what is this thing executing? Where are we standing? But once you have a benchmark, you can run it and attach any sorts of tools like flight recorder, for instance, and mission control. You can use these sorts of tools to capture the profiling. I mean, you use profiler. How do you drill down? You use a profiler. The JMH does not give you magic besides these things, where you get spit out annotated assembly code with a percentages spent. If you're into looking into assembly code and you can relate back to what it comes from in your Java code, then yeah, you might use this. But yeah, another question. Seems like I was really, really fast, man. Okay, we have some.
Well, I'd like to know, how do you analyze the results? For example, once you figure out that there is a problem in your code, what are the first steps to take to understand what is the clue of the problem, besides going to Google or Stack Overflow? For example, probably the first step you do is to pass a flag that you need the assembly printed, or something like that.
That's not going to be definitely my first step, for sure. I'm not going to print assembly, and maybe some people in the audience will, if they do sort of low-level performance work. Usually, if you're benching something that runs for an hour, let's say, your problem is somewhere, interaction with database, your network, your file system. Very, very rarely it's in the code where you just messed up the order of the algorithm. Let's say you iterate over array list instead of doing a hash map get or something. But you do normal stuff as with normal performance work. You say it's slow, you get some measurement. If you're into more theory on measurements, performance methodology, there is a great talk by Alexei and Kirk Pepperdine that was given at Devox some years ago, about three years ago, which is like 3-hour university. How do you approach performance problems in general? And it's much more complicated than just like I fire the tool and I get the numbers, and then you stare at the numbers. there is a process of how do you identify, for instance, the dominating consumer. The first thing you do is not even, you run your application and you look at the output of the CPU. What is the user time, what is the system time? And like, is my CPU used or not? And then they have a nice graph which kind of leads you, oh, if the CPU time is less than a certain threshold, that might be this. Or if it's bigger, that might be that. So it kind of gives you an areas to start looking at, even without jumping to the profilers. Because I can have a performance problem, run 4 different profilers and get 4 different answers. So which line of code I'm going to tune? Then basically comes your experience and like, okay, I know actually it tells me that this whatever little line is the problem, but I know that the line before is dumping 1 terabyte of data to disk. So probably the problem is there, not the line that gets reported. Yes. Microphone.
As you run your long kind of enterprise benchmarks, do you use single shot mode to capture the results or not?
This is exactly what we do.
And how do you approach analyzing that? Do you plot each and every single shot over time? So what do you do with that bunch of numbers actually? Do you trim, warm up? Do you figure out if there are outlines in between? So what's the best practice there?
Well, the thing is, it's a bit of a mix of all of that. I think we don't use only sample time at the moment. So if we measure fast operation, let's say some utils class that does something, you use either throughput or average time. You use these things which warm up your code quite significantly, they average your results, so you deal with run-to-run variance and stuff, you run them millions of times, etc. But for big ones, first of all, you don't want the repetitive runs of a single thing. So you want to say something like, run the thing 1 time, but you use more than 1 iteration. So if it runs, let's say, for half an hour, I will still use 2-3 iterations, and I will still use a couple of forks. So even that thing will be run several times. And then it's up to you. You can say, okay, I have 3 iterations. 1 will be warm-up iteration and 2 measurement iterations. So you can still do a warm-up, but it might not be the real warm-up thing. The thing is that if your job takes a long time, that what needs to be warm-up is inside that method. There are probably loops and stuff like that which will get warm up during the first measurement, and not the method call itself. If I have a single method, I have to warm it up because there are like 5 bytecodes there. So this thing must be formed up and jitted. But if I call something massive that talks to distributed storage or whatever, then it's somewhere there. So it depends what you're willing to tolerate. I mean, how do you approach this thing? Even if it's using single shot mode, doesn't mean that you have a single number. You just say, benchmark run this thing and don't care how much it runs because it runs half an hour and not 1 second or whatever, 1 microsecond or whatever we're measuring. Okay, that's it. I guess we have some more questions.
Can we get more information than average time? How about confidence intervals and minimum, maximum time?
Well, there is this fancy mode here, which gives you sort of this. The problem is the overhead of actually measuring time.
You're not answering the question that was posed. Yeah, for average time, can you see the confidence intervals and mean max?
Yes, you can. It's reported by JMH. It's just stripped out from all this output. So here, there is more stuff. There is an error. And before that stuff, you have statistics. You have confidence intervals. You have mean, max, and average shown. So all the math is shown to you.
Okay, thank you.
Yes. But if you want to have percentiles and distributions and more stuff, then you need to look into the sample mode. The problem is the harness cannot measure each and every invocation of the thing to measure, because usually getting the timestamp, the nanosecond, takes longer time than the thing you are measuring. So therefore, you don't want to introduce a huge error by calling the time around every invocation. So this mode, as the Java doc says, measures some of the benchmark method calls for some definition of sum and random. So it samples, hence the sampling time. Okay.
But it's not latency measurement. That's important to understand. It doesn't measure latency.
Yes, because you cannot measure each and every invocation, right? Because measuring the time.
Because you run at the maximum speed that you can possibly do, and that's not the way you measure latency.
Okay.
You want to have a load control. JMH does not have load control.
Yeah. True. Oh, one more question. Oh, and we're out of time. So let's take last question.
I'll try to be quick. You said that your benchmark tests last about 38 hours.
Yes.
And you have only one single isolated benchmark system.
Yes.
Wouldn't it be better to have a set of benchmark systems and to use benchmark tests in continuous integration mode, kind of?
I would love to have that, but the problem is then your systems must be identical or very close to each other. You have to have a control to make sure that, let's say if they are not identical, then you have to make sure that the same benchmarks always run on the same machine. Otherwise, you cannot compare numbers anymore. You can't compare apples and oranges. By just having one machine, I mean, it's also a question of money, right? How much the organization spend on that stuff. So we are lucky to have one machine on which we can run our stuff and nobody messes with us. You know, we control our database disks and etc. So and we leave it as is, as it was set up. And the only thing we did, for instance, we updated from JDK 7 to JDK 8, and even this was a bit of a pain because all your numbers that you collected so far kind of change. So you reestablish new baseline with JDK 8. So first thing we did when we migrated a new version of a product to JDK 8, we just rerun the benchmark and said, this is a new baseline. All the performance work we're going to do now will be based on these numbers. We're not going to look at JDK 7, it's irrelevant. We are now on different Java version.
Or you can show in another 38 hours and come do the baseline every time you do the test.
Yes, or that. True. Yes. Okay. Thanks for coming, guys. It was a pleasure. Hope you learned something.